In this lesson, we'll review a problem-solving data analysis question, and calculator is permitted. A researcher wanted to know if there's an association between exercise and sleep for the population of 16-year-olds in the United States. She obtained survey results from a random sample of 2,000 United States 16-year-olds and found convincing evidence of a positive association between exercise and sleep. Which of the following conclusions is well supported by the data? There will be a few questions involving samples and surveys, and whenever you see a question like this, there are two factors to consider. First, we have the entire population. And what this researcher is doing is taking a sample of the population, a portion, and trying to make some inference about the whole population, not asking every person in the population, just the sample, and making some type of conclusion. And the two factors that you have to consider is, first, the sample and the population have to have all of the same factors. Otherwise, you could not make an accurate conclusion. And number two, it has to be random. Can't just be a very isolated segment of the population. It has to be a fair cross-section. And so let's take a look here. The researcher wants to know if there's an association, a connection between the two factors of exercise and sleep. And here's the population, 16-year-olds in the U.S. She obtained survey results from a random sample, so that's good. If it's random, it's a fair cross-section. 2,000, definitely enough. It's certainly high enough to be a fair sample of 16-year-olds in the U.S. And so this, you notice, 16-year-olds in the U.S., 16-year-olds in the U.S., these are both the same. And so we can make some type of inference because we have the sample the same as the population. Which of the following conclusions can be supported? A, there is a positive association between exercise and sleep for 16-year-olds in the U.S. This looks good. Positive association means they just move together. And that's what the data from the sample showed. There was a positive association. If you think about this, let's say graphed, if we had sleep and exercise on each of the axes, it would have a positive slope. That means they move together. So we definitely, this looks good, could make this conclusion. B, there's a positive association between exercise and sleep for 16-year-olds in the world. Remember, the population only included 16-year-olds in the U.S., and that's what the sample did. You can't make any inference if the factors are not the same. C, using exercise and sleep as defined by the study, an increase in sleep is caused by an increase in exercise for 16-year-olds in the United States. So even though this is the same, the population as the sample, we have this word cause. You want to be very wary. If you ever see the word cause with a sample question, it will be wrong. Because if you think about it, all we know is that these two factors move together. They have a positive slope. We have no idea if one causes the other. There even could be a third variable. And so you never want to select an answer choice with cause. It's too extreme. We just don't know that. There's also a famous cliche in statistics you may have heard, and that is correlation does not imply causation. Just because two factors move together, we have no idea if one caused the other or if the third factor. So don't pick the word cause. Always stay away from words like never or always, extreme language, because even if the sample is very convincing, it's very, very positive, we still can't make definitively these types of statements. You want to pick words like likely, more moderate choices. And let's take a look at D. Using exercise and sleep as defined by the study, an increase in sleep is caused by an increase in exercise for 16-year-olds in the world. We know this is wrong because it has the word cause, and so all we can say is that these two move together. There's a positive association, and so the answer is A.